Hello dear student. Today we are going to discuss about the trigonometric identities. So first of all, we have to understand what is an identity. Identity is nothing but an equation is called an identity. Any equation is called an identity when it is true for all value of the variable involved. Just in the real life, if we want to understand the meaning of the identity, so just with the help of the nature, like sun rises in the east, this is true for all people in this world, either they are staying in India, US, Japan, Canada, anywhere. So this is nothing but the identity which is true for everyone. Same way in the equation format, the meaning of the identity is which is true for all variables. Whatever the value of you will substitute in the particular variable, it will give you the same result. Now, an equation involving trigonometric ratio of an angle is called trigonometric identity. Now, with the help of some formula that we can see, that is nothing but that called trigonometric identity. Sin square theta plus cos square theta 1. 1 plus that is sec square theta minus tan square theta, that is also 1. Cosec square theta minus cot square theta, this you can write sec square theta minus tan square theta, this is 1. This is second is cosec square theta minus cot square theta is equal to 1. So in this way, if you will substitute the value, any value, but both values should be same. If any value of the theta, suppose you will put, then always it will give 1. Always it will give 1. Similarly, in the sec square theta minus tan square theta, always it will give 1. Whatever the value of the theta is it is immaterial. So, an equation involving trigonometric ratio of an angle is called a trigonometric identity, and it is true for all value of the angle. Now, we will see with the help of some questions. And just you remember all these 5 formulas. Sin square theta plus cos square theta 1. Second is 1 plus tan square theta equal to sec square theta. 1 plus cot square theta equal to cosec square theta. Tan theta equal to sin theta by cos theta. Cot theta equal to cos theta by sin theta. And tan and cot product, that is reciprocal, is always 1. So based on that, we are going to solve the problem. So first, we have to prove all the 4 questions. We have to prove this 1 minus sin square theta sec square theta. This is 1. Now the common sense way how to solve, just you try to understand. This is nothing but sec square theta, and opposite of that is cosec square theta. If cosec square theta will come, so 1 minus sin square theta is nothing but cosec square theta. And cosec square theta and sec square theta is reciprocal. So just this is 1. Similarly, question number 2 we will see 1 plus tan square theta cos square theta. Same way, the opposite of cos is sec. So we will get the value of sec square theta from here. So this will cut, this become 1. Similarly, third we have to prove, that is it's also equal to 1. So 1 plus tan square theta, 1 minus. Now in this, first of all, just you see this is nothing but 1 minus sin square theta, that we can write cos square theta. And this is 1 plus tan square theta is sec square theta, just both the value will cancel. And this is equal to 1. Now question number 4. In the question number 4, if you will see 2 cos square theta plus 2 by 1 plus cot square theta is equal to 2. That is only possible when suppose 2 is here and 2 is here. So here, if suppose sin square theta will come, then automatically sin square theta plus cos square theta become 1. So in the fourth, 1 plus cot square theta, this is the value of cosec square theta, and 2 cos square theta plus 2 sin square theta, that is equal to 1, and 2 into 1 equal to 2. So in this way, we can find out the value. Now, question number, next question we will see. Prove that cos² minus 1 equal to tan²θ. And this is also the same question. cos²θ, this is tan²θ. So cot sec²θ, we can convert it into the 1 plus cot²θ. Thus 1 will cancel and this become 1. Now similarly, second question, sec²θ 1 minus cos sec²θ. So sec²θ we can write 1 plus tan²θ, this is minus 1. 1 minus this we can write 1 plus cot²θ. Now if this will cancel, this is tan²θ and this will cancel and this is minus cot²θ and this is reciprocal to each other, so this is minus 1. So in this way we are proving all the from the value whatever the question is given. Now in the question, next question, sin²θ plus cos²θ divided by sin² cos²θ, this is the value. So in this way, first of all, what we can apply, this is the formula. So AQ plus BQ, that is nothing but A plus B, A square plus AB square minus AB. This is the formula for AQ plus BQ, and sin² plus sin² into cos²θ. Now this will cancel, and here sin²θ plus cos²θ is equal to 1 minus sin² cos²θ. So this is the value. This will cancel. This become 1. Next question. We have to prove that sin² minus cos²θ, cos² minus sec²θ. This is the value. Now in this type of question, what we have to do, first of all, we have to find out the left value. Whatever the result we will get, after that we will find out the right hand value. Just if both the value are same, then only we can say this is equal. Now technique is, whatever the, apart from sin and cos, whatever the value, first we have to convert it into the sin and cos. So cos² is nothing but 1 by sin². Sec² is 1 by cos². This sin²θ here minus 1 by sin², cos²θ minus 1. Now this we can write minus, if we will take, this is the formula, 1 minus sin² is equal to cos²θ, and this also just take minus outside, so 1 minus cos² equal to sin²θ, minus minus plus, and sin²θ cos² divided by sin² cos², this will cancel, and this is cos² into sin². Same way, right hand side, first of all, take the right hand side, tan θ, sin² by cos², cos² by sin². Just take the LCM, and after that this becomes sin²θ, cos cancel, sin²θ, sin² will cancel, this becomes cos²θ here. Now this will go in the numerator and this is equal to 1. So this is the value. So whatever the value in the left hand side and right hand side, both value are same. This is the left hand side and this is the right hand side. Now next question. All the questions we have to solve in this way. So this is very easy actually. Now 1 plus cot² cosec², 1 plus tan² sec². Now in this, first of all, convert the cot² by cos² sin², cosec² 1 by sin², tan² sin² by cos², and this is the value. Now after that, just taking the LCM, this is sin², this is the value 1, that is nothing but the 1 into sin² is sin², this is cos² minus 1, cos² plus sin² plus 1. Now here sin² plus cos², and here also sin² plus cos². So just we have to write in the same order, sin² plus cos², this is minus 1, and this is nothing but a plus b, a minus b. So sin² plus cos² whole square minus 1 divided by sin² into cos² we have to write, and just we have to expand by a plus b whole square, and this is a plus b whole square, a square plus b square plus 2ab minus 1. This is equal to 1. So this and this value will cancel. So this is cancelled, and 2 sin² cos², 2 and sin² cos² in the denominator. So this value will cancel, and remaining is 2. So in this way we can prove the value. Next, sin theta minus 2 sin q theta by 2 cos q. So wherever this type of question is there, so tan theta, how it will come? First of all, the common sense is sin theta by cos theta. So sin theta we will take common from this, and cos theta will take common from this. So this become 1 minus 2 sin square theta, 2 cos square theta minus 1. First of all, we have to write. Now, this is nothing but the tan theta. So this value and this value is same. Then only it's possible right hand side will come. So first of all, convert any one. Here sin square theta. First of all, try to convert it into the cos square, well, cos format. So we can write 1 minus cos square theta. This one we can write 1 minus cos square theta. And thus once we will calculate this, this is 2 cos square theta. This is 2 cos square theta. This will cancel and this is tan theta. So in this way we can prove. Now tan A by 1 minus cot A. Cot A by 1 minus tan A equal to 1 plus tan A cot plus cot A. So this value, first of all, convert it into the left hand side. First of all the value we have to convert it into the sin and cos. So tan A we can write sin A by cos A, cos A by sin A. Here cos A by sin A by cos A. After that, taking the this is nothing but sin A minus cos A, and this sin A will go in the numerator part. So sin square A, cos A, sin A minus 1, sin A minus cos A. Similarly, this ones will take cos A minus sin A. Cos square A will go up. Now, if we'll see this value and this value, this is just the opposite. So in this we will, what we will do? Take the minus sign. So this is equal value. This is same. Order should be same. So after that, just taking the LCM, sin A cos A, sin A minus cos A, and this becomes sin QA minus cos QA. Just you have to solve, and after that here we have to apply AQ minus BQ formula, A minus B, A square plus AB plus B square, A square plus B square plus AB. So this value is 1. Now sin A, this sin A minus cos A, this will cancel. 1 plus sin A by sin A into cos A by this is the value. After that, same way we have to solve for the right hand side. 1 plus tan A plus cot A. Once we will solve, we will got this value. So 1 plus sin A into cos A by sin A. Next question, cosec A minus sin A, sec A minus cos A. We have to prove this value. So in this, first of all, cosec A minus sin A, sec A minus cos A. First of all, convert into the sin and cos, and 1 by sin A, this is sin A, 1 by cos A, cos A. So by taking the LCM, this value we got 1 minus sin square A, that is cos square A, sin A square A, and this 1 cos, 1 sin will cut, and this we got. Similarly, in the right hand side, just we have to prove this value. 1 by tan A plus cot A will got this same result. Now, next question, 1 plus tan square A, 1 plus cot square A, 1 minus tan A. Now we have to prove tan square A. Now, first of all, just see the value. 1 plus tan square A is nothing but sec square A directly. So it is not required to convert here. And 1 plus cot square A, that is nothing but the cosec square A. Just taking the reciprocal, we got sin square A by cos square A. This will become tan square A. So directly from here to here, this is proved. Now in this case, when the square is in the outside and minus is there. So once we want to prove this, so 1 minus sin A by cos A, 1 minus cos A by sin A. So cos A minus sin A by cos square A, we can take outside square, and this is also square. So this is nothing but this value is this value and this value, both value are same actually, because this is in the square format. So this value will cancel, and this is sin square A by cos square A, this become tan square A. Next question, tan A plus sin A by tan A minus sin A, we have to prove this value. So Here we have to convert this into the tan A, that is sin A by cos A, sin A by, and this is sin A. Sin A, if we will take common, then 1 by cos A plus sin A. Here also same thing. So sin A will cancel 1 by. So this is the value, and reciprocal of that is sec A. So that is very easy. Similarly, question number second, cot A, and here cos A. So we have to convert this cot A into the cos by sine, and cos we have to take in the numerator and denominator, take the common outside. So 1 by sine A. So this will become cosec A minus 1, cosec A plus 1. Now, next, cosec theta minus cot theta, that is 1 minus cos theta, 1 plus cos theta. That, first of all, we have to convert this into the cosec minus cot, 1 by sin theta, cos theta by sin theta. After that, just take the LCM, and the square of that is nothing but 1 minus cos theta whole square, sin square theta. This we can write 1 plus cos theta, 1 minus cos theta, and this is 1 minus cos square theta. So this value we can write a plus b, a minus b. Just to cancel this, we will got this result. Now sec² theta minus sec square theta. So sec square theta is nothing but the common. So sec square theta minus 1. We can write 1 plus tan square theta and 1 plus tan square theta minus 1. So 1 will cancel, and this is the value. So tan square theta plus tan² theta. This is the way we can convert. Now next, 1 plus 1 by tan square A, 1 plus 1 by cot square A is this value. So in this case, just take the 1 by 1 plus tan square A, that we can take 1 plus cot square A, and 1 plus 1 by cot square A, this we can take 1 plus tan square A. This, the value is directly formula based, and this is cosec square A and sec square A. Convert this into the sin A and cos. So this become 1 by sin square A, cos square A. Now whatever is required, based on that we have to convert sin square A, 1 minus sin square A, and this is the RHS value that we have to prove. Now, this question is very, very important. Here sin theta, cosec theta, that is nothing but the reciprocal value is given. So first of all, we have to expand this a plus b whole square format. Here also we have to expand this. After that, we have to arrange the terms. So sin square theta, cosec square theta, and this will cancel because they are reciprocal to each other. So sin square theta plus cosec square theta we have to take from here, plus 4, this plus 2 plus 2, 4. After that, cosec square theta plus sec square theta. Now, this become 1. This is equal to 1 plus 4 and 1 plus cot square theta, 1 plus tan square theta. So we can write 7 plus tan square theta plus cot square theta. So this is the RHS value. Now next question, 1 minus sin theta by 1 plus sin theta. This we have to prove sec theta minus tan theta. So in this type of question, if you attempt from the right hand side, then it is easier for you. So in this question, sec theta minus tan theta, first of all, we have to convert into the 1 minus cos theta, sin theta by cos theta, taking the LCM and doing the square. After that, in the denominator part, 1 plus sin theta, 1 minus sin theta, one value will cancel, and this is the required result. Similarly, second question also we can do, where cosec theta and cot theta we have to convert 1 by sin theta, cos theta by sin theta. After that, 1 plus cos theta ka whole square. This we can write. Now this is nothing but 1 plus cos theta, 1 plus cos theta. But in the denominator we can write 1 minus cos square theta, and we can convert in this way, and this will cut, and this is the result that we have to prove. So I hope you got the concept how exactly we are doing the questions of the trigonometric identities. So only 5 to 6 formulas are there, and some tricks are there that you have to apply and solve all the problem. Thank you.